So let's look at this problem. What it says here, it says that determine the magnitude of the resultant force and its direction measured clockwise from the positive x axis. Resultant force. What's a resultant force? Can anyone tell me what's a resultant force? Say again? Sum of all forces? Okay, so my question is, I'm sitting on the table. What's the resultant force? What's the resultant force? What's my resultant force? My weight. Okay. So remember, if I pick this book and ask you what's my resultant force, that is this book plus my force. Okay. It's not always sum of all forces equals 0. Is that clear? So determine the magnitude of the resultant force and its direction measured clockwise from the positive x-axis. So what we've got here, we've got two forces, F1 and F2. It's an eye bolt. You've got two forces acting on it. So the easiest way, two forces make a triangle. Head to tail rule, join the resultant, you got a triangle. Now what's given here? The very first thing to solve any problem, not only numerical, even real life problem, is the diagram. You make the diagram, you will be able to solve the problem. If you do not make a diagram, you will not be able to do that. Okay, so diagrams, free body diagrams are very important. Even today, when I get a problem from the industry, the very first thing I sketch down the free body diagram. And just to give an idea to the customer that how complicated will be the solution and how much it will cost. I cannot do the calculation there and then. I need to get the quotation of parts and everything, but I quickly jot down a free body diagram, figured out what are the forces involved, what kind of loading is there, and then I can figure out the cost and things like that. The free body diagram is very important. Okay, so you got a problem here, and you got the diagram. Look, that's a real world problem. I bolt two forces, and you simplified to a triangle. Now it's easy to solve. If you had only that real life problem pictured there, it was a bit confusing how to find the resultant force of those two. Okay, so diagrams are very important. So now you've got two forces, F1 and F2, both are given here. That's your, okay. Come on. Okay, so you got your F1 and F2 here. I want to change the color of the pen. How can I change that? Pointer option, pen in color, and I'll go for red. Okay, so I've got my F1, which is this one, and I've got my F2, which is this one, head to tail. And then I've got my resultant given here. That's my resultant. I've got the triangle. Now it's very easy to solve. What method are you going to do? Yeah, simple as I won't go into the details. You got your sine cosine law, you apply that, and you got your force and angle out. So question is this right? Have a look. Is it right? The answer. Say again? The angle is measured, in this case it's measured anti-clockwise. You sure? Look at beta angle and then tell me, are you right? You're not sure. Anyone else? Come on. Shall we move to the next example? Shall we? No. Look where you stand. You're not even confident about clock and anti-clockwise. Is the answer right or wrong?
Wrong, sir.
It's wrong. So be confident. Say again? Yeah. Yes? What happened to that? Figure it out. The question is, I want to give a message here. Look, be confident. The angle is here is measured clockwise. The question is, clockwise. And the angle given here is anti-clockwise. So what's the answer in clockwise? Okay. Which one? The top. Okay, why is that? Let us have a look. So you've got F1 and F2 given, okay, and you are after your resultant, and the angle opposite the resultant is there, 180 minus theta. So you're saying that this thing is wrong, am I right? Why?
So that's not the problem. If we want to get anti-clockwise angle, we just subtract this angle from 360.
The question is, I'm coming to this part. This one here. Why 180 minus theta?
जो ऊपर हमारे पास डायग्राम है ना उसके अंदर हमें इन्होंने थीटा दिया है वो 120 है।
Yes.
अगर हम एक लाइन ले और लाइन पे जो एंगल होता है 180 का होता है एक स्ट्रेट लाइन हॉरिजॉन्टल लाइन। तो अब अगर हम इसका
Are you sure a straight line has got angle of 180?
मतलब जैसे अगर एक सेमी सर्कल बनाए।
Are you sure? My question is, are you sure?
Yes, sir.
Yeah, be confident. Okay. So basically, that's 180 minus theta.
Yes,
Theta is given, that's 120. So that angle is 60.
Yes, sir.
What's the problem with that?
When we are calculating the resultant of two vectors, we always consider the angle between the tails of the two vectors, and it is given in the statement and the figure it is given with the statement. It is the theta between the tails of the two angles F1 and F2. We deliberately F1 with the head of the F2 for our convenience.
No, there are two. Hold on. You got two vectors. What did I say? I said you got as many vectors as you want, and you can combine them in any order you want. You've got two vectors here. You've got F1 and F2. So I first draw F2, and then I draw F1. I can draw first F1, and then I can draw F2. Okay? So I have not changed the direction of the vectors. Remember, you do not change the direction of vectors. So I've got my F2 and F1 there. Okay? And I've then linked my tail of F2 with head of F1.
The angle between the two vectors is 120 when we are calculating the resultant. We consider the angle when we join the tails of two vectors.
That is when you do it on scale, not when you're using trigonometry. It's the same thing. The angle between the two vectors is how much?
120.
120. Is it 120?
In the statement, it is 120.
That's my vector. That's my vector line. Now tell me what this angle is. So, what's the difference? Hmm?
The one with just 60 degrees is
Yeah.
the negative x-axis.
It's a straight line. What's happening here? I've got my two vectors here. I can take this angle or I can take this angle. Doesn't matter. Okay? So to use cosine and sine law, I need a triangle. I need a triangle. So to make life easy, you get a triangle out. Okay? And then you apply your sine cosine law. Is that clear?